Alright guys, welcome back to the course. So in the last lesson, we gave an AI a saved image and asked what it could see. Today we close the loop. Our drone will take off, look at the world through his own camera and ask an AI what he sees and use that answer to help plan his next move. So let me show you the simulated world. It's a wind inspection farm. So it's when the drone takes off that you guys will see the turbines. So step one, connect, go to the cloned LGBT, make sure you go to your terminal. I'm using the Linux, so the other videos might be in Windows, but this is like for Linux users to Jupyter Lab, to start Jupyter in your Chrome. This is really amazing. So I'll run this locally. So this is what it looks like. So we need to get both the simulated world and also the Jupyter world side by side. Let's go. Alright, so we're going to shift this here. So run the commands. Alright, so I already ran this earlier, that's why it's looking connected. Alright, so because it's using natural language commands, the drone operates under LLM control, taking or performing visual perception and then making decisions based on perception results and executing action. So it means that it sees what is there, it then makes its decision, and then when it makes a decision as an AI agent, it then performs that action. Perception. So here is implemented through LLMs, multimodal capabilities, leveraging its image understanding. So implementation is divided into two levels. The lesson, the LLM can handle targets, but we need to tell the LLM the target's position and then test its reasoning capabilities. In the next lesson, the LLM needs to identify both targets and locate their positions, objects, and then execute the target approach tasks. So the second lesson here is, it's not this environment, so we need to get another simulator. It will definitely be in a new video. So this is running. I already ran this earlier. I connected it. It should show connected. And then the next one is to take off. So we already have commands here where the drone can take off, fly to a particular point, target X, Y, Z. Also, I'm going to run this and you see how the drone, if I run the command, you see how the drone will take off. So this is the command, that's the drone. I'm running it, the drone is taking off. So I'm giving it specific locations on where to go to from point A to point B. So it's moving. So this is a simulator, I'm not controlling this, I'm controlling it from the code. I'm not necessarily doing any maximum work, I'm just running commands. So now, giving vision to the drone. Based on the SIM wrapper function, the drone should be able to detect what's in its front and then send information to the AI agent. Alright, so let's show you. So if you look at this function, look, so it has grab, where you can read the image, and then convert that image to a base 64, which you can travel to the internet like any random message. and then send it to a multimodal AI model with one plain question: what is this image? The model looks at the picture and writes back a comma separated list of names. That's it. That's how the drone gets its eyes. So we see function here where a particular image has been converted to base 64, and then this is the rulebook. Let's call it the rulebook, where you see the functions here. If the function is not here, it cannot happen. So let's say if we don't have a fly 10,000 meters per hour, ironically speaking, drone level, it cannot happen here. So we look at what we have here. So this is the AI parts. Although the first cell is connected, drop the next video where we have full connected AI agent. So that's basically it. Make sure you load it from the directory where you have the multimodal app. See you next video, guys.